This is the last one. Super irritating because there's that k. So basically you're going to be playing around with it. Just like we did with our inverse function and just like we did with our a, it's just irritating because it's just a lot of manipulation and the algebra is irritating. So obviously f prime, f double prime, super standard. So we're going to say f of x equals k to the square root x minus ln x. So when we're taking the derivative of this, f prime of x equals k over 2 x to the 1/2 minus 1 over x, or x to the negative 1, however you want to write it. Main thing that we're doing here is we're just making sure to be careful because k is a constant in this case over here. So we're not doing chain rule, we're not doing product rule, anything like that. So then f double prime of x is going to be equal to k over, oops, excuse me, this is a negative, almost forgot, k over 4 negative x to the negative 3 over 2 plus 1 over x squared. And again, this is just very simply, I'm going to write x to the negative 2, just to keep it in line with our previous term. And again, just be very careful of your negatives. Very, very mechanically simple, or ideologically simple. Just watch out for your mechanics. So that's it for A. We figured out A already. A is done. So now B, it says, for what value of the constant k does f have a critical point at x equals 1? So let's figure that one out first. So basically, again, to be a critical point, what I need to know is f prime of x is equal to 0. And specifically, I want that to happen at 1. All right, so let's figure this out. So we're going to say 0 equals k over 2, 1 minus 1. Okay, and again, basically what we're going to be doing is we're just plugging in all of our numbers. Oh yeah, I was about to say, I feel like I dropped a negative somewhere. Yeah, watch out for your negatives. And then from here, we're going to get 1 equals negative k over 2, which means negative 2 equals k. Okay, and then next. Okay, sorry, I was like, I swear I'm taking crazy pills. I swear this was 2. Yeah, it is 2. I mixed up my f of x and f double prime of x. So I'm going to just rewrite it so I don't screw up. F of 1 equals, or f prime of 1, because again, critical values is where your derivatives equal 0. F prime of 1 equals k over 2 times by 1 to the negative 1/2 minus 1 over 1. And then from here, we're going to have 0, because again, that's what we want, equals to k over 2 times by 1 minus 1. So then 1 equals k over 2. So k equals 2. Again, I'm going to just erase all of this. So 2 equals k. And then next, we got to answer the rest of the question. It says this is a critical value. For this value of k, determine whether it has a relative minimum, maximum, or neither. And again, when you're doing this, there's a couple of ways that you can do it. You can either do a sign chart, do your positives, negatives. However, in this case, it's generally better to just do your second derivative test. So again, either going from negative, so one way to tell is going from negative to positive on your slope means that it's a minimum. Going from positive to negative on your slope means a maximum. Or you can do concave down. That's going to be a, if it's concave down, if your numbers are negative, it's concave down, and then that's going to be a max. If your numbers are positive on your second derivative, it's concave up, and that's a min. And since we already have our second derivative function here, we'll just plug it in. So what we're going to do is we're going to have f double prime of 1 equals 2 over 2 times by, or excuse me, we're using our f double prime. So negative 2 over 4 times by 1 to the negative 3 over 2 plus 1 to the negative 2. And again, the reason why this is no longer k is we said that we're doing this function with the assumption that k is going to be equal to 2. And then from here, we just check f double prime of 1 is going to be equal to negative 1 over 2 plus 1, and then this is a positive number. So that means it's concave up. So what we're going to say is this is a local min since f double prime of 1 is positive, which means the function is concave up. Okay, again, all that for B. So we did that. Minimal, maximum, neither, did that. And then finally this over here. For a certain point that has an inflection point on the x-axis. Okay, so this one is kind of irritating. So inflection point is where f double prime is equal to 0. On the x-axis is where f is equal to 0. So we're going to keep this in the back of our mind as we go forward. So first things first, I want to find where f double prime is equal to 0. So 0 equals negative k over 4 x to the negative 3 over 2 plus x to the negative 2. And then from here, what I'm going to do is I'm going to say 0 equals, and I'm going to factor out a negative 2x. So then I have x to the negative 2 times by negative k over 4 x to the 1/2 plus 1 equals 0. And then from here, what we're going to do is we're going to do our zero product property again. So either x is equal to, well, x can't work because that's in the denominator, so this is going to be equal to 0. So what we're going to say is 0 equals negative k over 4 x. I'm going to write square root of x is a little nicer for me, plus 1. So I'm going to say k over 4 square root x equals 1. And then I'm going to get k equals square root, or 4 over square root of x. So again, I'm solving for k. This is what k is going to be equal to, but again, that's not an actual number. So now we're going to need to use the fact that it's also going to be on my x-axis, and this is going to give me a nice system. So I'm just going to box this, hold on to this, and then I'm going to have to find out where f of x equals 0. And then what we have for our f of x function was k square root of x minus ln x equals to 0. So then from here, I'm going to just go k square root x equals ln x. So k equals ln x over square root of x. I'm going to reduce my face again. All right, so then now I have two equations for k, and I can use system. So I can say 4 over square root x equals ln x over square root x. Now, obviously, these two denominators are the same, which means the only way this works is if my numerators are the same, which means 4 equals ln x, which means this is e to the 4th is equal to x. And then from here, in order to find k, I plug it into one of these two, 1 or 2. So I'm just going to plug it into this top one over here. So we're going to say k is equal to 4 over square root e to the 4th. So k equals 4 over e squared. So again, it's giving me two pieces of information: point of inflection, x-axis, two equations, two variables. This is a systems problem. Again, such a little problem, but so much irritation on this. Again, it just takes the idea of what does it mean to be a slope? How do we take derivatives? It's just mechanics and just adding on this extra component. Again, irritating problem. Honestly though, this is just a really common problem where they give you a variable in your equation and you just have to solve for it. The A problem where it was like a x double prime of t and whatnot, that's super common. This is super common as well. So just keep an eye out for it. Again, that was our first run through of 2007. So we're going to be doing this for a few more chapters. I am going to be giving you some free response. Again, the main goal now is to take the mechanics you know and kind of solidify them. So we'll try to figure out what were some of the questions that you had, what were some of the things that you just absolutely didn't understand what I was saying, what did you not get, like what steps I looked for and whatnot. I will be uploading the PDF that I'm working with currently, as well as the original AP exam, and then we'll probably go over the scoring guide as well. Okay, if you guys have any questions, let me know. If not, I'll see you guys later. Have a nice weekend.